Hi, this is Mike Hendrickson from Software Architecture in London. I'm here with Liam Crilly. Liam, how you doing?
Great, thank you. Great to be here.
So you're with NGINX, and what I know of NGINX is you're a high-performance web server. Are you a web server, or what is NGINX?
So, yes, we absolutely are a web server, but we're a lot more than that. And many of the users of NGINX came to us from that web server use case. So the reason that NGINX was originally envisaged and built was to provide high-performance web server that could manage the amount of traffic that, frankly, at the time, Apache couldn't manage. It was essentially, you call him now a DevOps engineer, a guy called Igor Sysoyev. He was working for Rambler.ru, Russian sort of equivalent of Yahoo back in the day, and the Apache web servers just were running out of memory, and they weren't handling the amount of concurrent connections that the growth of the internet at that time was providing. So he set out to solve that problem. And at the same time, there was a computer science problem called the C10K problem. And that's 10,000 concurrent users on a single box, a single piece of hardware at that time. So Igor set out, he wrote a different type of architecture for how to build a web server. And it's an event-driven architecture, which is increasingly popular these days for high-scale web applications. It's the kind of architecture you need to be looking at and moving to.
Massive transactions.
With massive transactions, massive scale, hyperscale, as you might call it. And so he went and did this thing, and it worked for him inside Rambler. And what it allowed him to do was keep the Apache servers but not crash them. And he could handle all of the static assets and other resources from NGINX without having to put extra load on the Apache servers. And this evolved and evolved. So lots of people know NGINX from being a high-performance web server, and we absolutely are. But we're also reverse proxy. So we can sit in front of any web application. We can sit in front of any TCP or UDP application, for that matter, and be a reverse proxy and a load balancer. So when you scale, keep NGINX at the front end, you bring in all the additional instances that you need to run at the scale that you have. So you can scale horizontally, and of course that might be containers these days. And NGINX will manage the traffic, it will load balance it, and it will also cache it. So if you need another layer of performance on top, then once we've received an asset from a backend, we can cache it locally, and then the next request that comes along, we just send that. We don't even have to trouble the backend anymore. So there are a number of elements to NGINX, the web server.
So this is kind of the architecture of a high performance.
Absolutely, it is. Yeah.
Okay.
And we've seen that the way that people build applications more and more fits the model of having a high performance reverse proxy these days in front of an application. So for the busiest sites on the internet, we tend to be deployed perhaps as a web server, but most certainly as a reverse proxy.
So what is the big benefit of a reverse proxy?
Primarily, you get scale, you get reliability, you get consistency. So a client, the web browser, the API client, mobile app, whatever it is, it talks to one thing and one thing only, and that's a reverse proxy. And whatever happens at the back end, in terms of scale, in terms of outages, in terms of versions, you're doing upgrades, all of that happens behind the scenes. The client sees a very reliable, a very fast front end that it's talking to. It thinks it's talking to the website. In fact, it's talking to reverse proxy, that's us, and then we handle the other connections but to the back end. So that means the front end gets an easier job. It sees a very reliable, predictable web server, and the back ends, they see no longer do they have to deal with slow clients coming in from different countries and different network connections, different latencies, and they hold a connection open, waiting for the request to come in, and then they handle it, consuming memory the whole time. They see a reverse proxy. They see one client, a very well-behaved client, that doesn't do anything until it's got a complete request from the client, sends it across, we get a response back, and that means that the back-end apps get the best behaved, the perfect client they could hope for. They don't spend any time waiting for data to come in. They can just deal with the request and send it back. And that's the reason why you put an NGINX reverse proxy in front of your APIs or your backend web servers, and they can now handle more load than they could before, even though you put in an extra hop. that more than pays for itself.
Handle more load, but they also scale as well?
You can then scale it freely. So you've got this reliable single entry point in the reverse proxy, and then the applications can scale either full load for spikes, or just for high availability purposes.
So you can change the tires while you're moving at high speeds.
Can indeed.
Basically,
Yeah,
right?
yeah, in-flight refueling, whatever you want to call it.
Yeah.
And that has played very nicely with the shift towards microservices and the shift towards containerized environments, where these backends are now smaller units of deployment, either a whole app or part of an app in a microservices environment. And that means that they have inherently less capacity than your previous VM or your piece of hardware that was running your application. And that means you need more of them. You need at least 2 every time, just for high availability purposes, but for scale, you probably need more to handle the traffic than you did before. So what we're seeing is that load balancing has moved away from the edge of the network. It's no longer in control of the network team that run the edge, the periphery of your data center or your cloud environment. It's getting closer and closer to the application. And that, in terms of modern software architecture, is changing who cares about load balancing.
Who does?
So now
who is that? Yeah.
So it used to be the network team, right?
Yeah.
They handle the network. You had the firewall, you had the load balancer.
This one fails, we have this one.
Yeah,
Yeah.
And you talk to us and you tell us what applications you're deploying, and we'll very kindly set up some rules for you, and we'll send stuff down to your backend servers. So now I'm deploying containers. I care at a container cluster level, whether it's Kubernetes or Docker Swarm or whatever else. I've now got a new entry point to my network, into my container network. So DevOps Care and Developers Care, and that means that you can't do a cloud migration without bringing up some load balancing with you. You can't do a microservices containerized environment application without making conscious decisions about how you're going to do load balancing.
So the DevOps person is the app ops, basically the people that's delivering the apps.
Yep.
As well, and they're going to need that.
They're delivering the apps, and they've got a new responsibility in the world of microservices and continuous integration, continuous deployment. You're doing rapid changes to smaller units. So you need to also have a way of managing how you do an upgrade, because that's no longer once every quarter you schedule a weekend and you go do that stuff. That's now happening weekly, daily, sometimes more frequently than that. And so you can't have the process in place where you had to make a request for someone to change. I now need my API, pricing API now needs to point to these other servers, and wait for someone to do it. You are in control. So the DevOps, the app ops, if you like, these guys need to make those decisions themselves.
So decisions, like I see 2 main things going on with companies today. There's the large companies that are in a state of transformation. They're trying to get from old legacy to modern delivery, continuous delivery, agile type things. And then we see the disruptors that are trying to take over their industries and trying to erode business where they can. Do you have solutions for both of those camps, for the large transformers and then the smaller disruptors coming in?
We do, and this is what I love about microservices, is that it's so democratic. And it's many things to different people, but what I particularly like is we help customers who have the old legacy monolith that was much maligned, but probably and sometimes accurately and sometimes just something to poke a stick at. And they are solving business problems by taking out, by severing the limb that doesn't work anymore. The bit that doesn't scale generally is where the value is in moving to microservices. So by able to take that piece out, build the problem part as a microservice, and then start experimenting and start understanding the disruptor processes, if you like, is an absolutely viable and valid approach to a microservices project. And then we see the other side, which is the startups, the people without any existing infrastructure, existing software, existing anything.
Digital natives in a way.
Digital natives who get to build stuff from the ground up using the current best practice tools for building a high scale. They build for high scale from day one. And they're taking the microservices architecture and the DevOps practices that go around that for the continuous integration, deployment and integrated testing, and they're the poster children for this work. They are making applications that people have heard of. They're writing blogs. They're pushing stuff out to open source. They're making a big noise and being disruptive to an extent, because people then want to go, oh, we need to do it that way. We need to do it, this is the way to do it. And the best and brightest tech minds in the enterprise IT want to follow this process too. It clearly works. They get it, but they need to apply it to a business which has existing software, which has to keep running, and doesn't have the resources that they can just go spin up a whole new team and say, well, rewrite everything that we have now, but in microservices, because you try and build a business case for that, it doesn't really work. That's where there's a middle ground. Let's take what we've got and let's find the best way that we can adopt modern practices to remove pain that we have in these applications. And I think that's where actually disruption has a net positive effect on the business.
On the transformation.
Absolutely.
Yeah. So Liam, if you and I sit down 12 months from now, here in London again next year, what would you like to say changes for NGINX? What are you guys going to do differently or better next year?
So we're spreading our wings. At our user conference in Portland, Oregon last month, we announced several new products from top to bottom of the stack. So if I'll start at the top, which is our new flagship product will be NGINX Controller, and it will allow customers using our commercial offering of NGINX Plus to manage multiple instances through a web UI and an API, and to perform DevOps workflows. So when you're doing canary testing, canary deployments, blue-green deployments, you'll be able to stage those up in the UI, press the button, see them swap around, and then manage and track the stats to show that nothing is going red. And if stuff's going red, it's going back, stuff's going green, and you can shut down the old ones. And so that kind of archetypal DevOps workflow we're building into a rich UI for our enterprise customers to make that transition
and that's Controller.
Easier. That's called Controller. And then if we flip to the bottom end of the stack, we're also building an open source app server. So this is what lives inside, for example, your container, but not necessarily a container, that's running your application code. So you have NGINX at the front end doing that reverse proxy load balancing job that we spoke about, but passing it to another lightweight, high performance, container friendly application server that needs nothing else than it and the code. So it simplifies the application stack. So that is our application architecture that's for microservices finds the way that you configure, install, and manage the traditional application servers. And I'm talking for PHP, it would be FPM. For Python, it would be GUnicorn or UWizgy. For Ruby, you've got Unicorn Rack. So we are building one application server to handle all of those languages with a single piece of software, which means that either you can run multiple versions, multiple applications in the same container, but only with one app server, or for migration purposes, run different versions of the same programming language, again with a single app server. So we're trying to take the problem of how you build applications on a modern app server and apply what we've learned from running NGINX at hyperscale for many of the busiest websites on the internet, and what they need at the bottom end of the stack for actually running the code. So next year you're going to see
full stack.
Full stack, maybe not full stack for everybody. Different people need different parts, but we will have a full stack story and a whole range of analytics and monitoring in the middle through our amplified product as well. But that's been around for a while.
Liam, we look forward to that conversation.
So do I.
Thank you.
Thank you.